This is the completed 8080 computer system. The system units above the keyboard, the parallel printer, a DMP-110 from Radio Shack, is on the left. The monitor and keyboard is actually a VT100 serial terminal I built using a Raspberry Pi Zero 2W. It looks and works just like a Wise serial terminal from many years ago. If you've looked around for a working CRT terminal, you've seen that they've become a collector's item with asking prices between $350 and $500, which I think is absurd. So I built one using off-the-shelf hardware and software for about $125. I'm going to cover the terminal in a future article. It was quite a challenge getting 80-column, 25-line text using a modern high-resolution display. But I'm very happy with the terminal and all the things it can do. And I'm especially happy with what the 8080 computer can do. CP/M supports 4 logical devices: a bidirectional console device called CON, C-O-N, an output-only list device called LST, an input-only tape reader device called RDR, or reader, and an output-only tape punch device called PUN, or PUN. A feature of CP/M 2.2 called IO-Byte provides a way to map many different physical devices to one of these 4 CP/M devices. My system doesn't need a bunch of physical devices, so I didn't implement the IO-Byte feature. The first serial port is the console device. The parallel port is the list device. The receiver section of the second serial port is the reader device, and the transmitter section of the second serial port is the punch device. Tape reader and tape punch devices aren't of much use anymore on my system, so I decided to use the second serial port to connect the 8080 computer to my desktop computer. It can also be connected to a modem. The first application I'll use with this serial port will be the Kermit file transfer program from Columbia University. With CP/M, the easiest way to get the printer going is to press Control-P and then run a command that generates output on the console device. Control-P tells CP/M to echo anything sent to the console device onto the list device. A second Control-P stops echoing console data to the list device. So first I'll press a Control-P, and next I'll run the directory command. The directory command completed, let's take a look at the printout. As you can see, the DMP-110.matrix printer has created a hard copy of the information shown on the console. Now let's try printing a document from the WordStar application. What's on the console right now is a demo document called diary.doc. What I'm going to do is attempt to send that document to the DMP-110 and see what happens. First, I'll exit back to the main WordStar menu, and then I'll press P to print the document. Diary.doc is the document I want to print. I don't want to pause between pages. No form feeds. Starting page is 1. Ending page is 2. Non-document is no. I'll use the draft quality printer configuration for this. And the printer just starts printing. course, this might be a lot more impressive if it was a laser printer or a daisy wheel, but still quite fun to watch. I also have Kermit running on the 8080 computer. I'll type Kermit on the command line to start the application. This will exercise the serial link I've installed between this computer and my desktop computer. I'm going to use Kermit to send every file on my D drive to my desktop computer with one send command. Send star. This is my desktop computer. One of the nice things about Kermit is that you can send a group of files in one transfer instead of one file at a time like Xmodem. The Kermit software on the 8080 computer is telling the Kermit software on my desktop when each file begins and ends, along with the name of the file. Kermit on a small computer like the 8080 is not very fast, but it is very reliable. It's been said that Kermit can send data reliably even if the network is just two tin cans in a string. Although Kermit's been stuck with the reputation that it is slow, on a well-equipped computer, it's faster and more reliable than X modem, Y modem, Z modem, and a number of others. It achieves this by using a full duplex windowing protocol, large window sizes, and real-time data compression. I'm going to let this transfer run, and I'll come back when it's completed. And as you can see, the transfer has completed, and we've got all of the files in the downloads directory. So let's take a look at the software changes that make all of this possible. I've moved the CBIOS to version 3.0, and as we scroll down through the list of code, one of the first things that I've done is I've added definition for serial 1. Serial 0, if you remember from a prior presentation, started at IO address 0 and went to IO address 7. Serial 1 starts at address 8 and moves up to address F. I've added some additional equates for some registers for serial 1. And then I've created a set of equates for LPT0, the parallel port on the back of the machine. And this just defines the registers as well as various bits that are inside of these registers. Pretty much what was on here in version 2. And then as we get to where we're going to initialize the computer, I've just added serial 1 in the 8250 initialization section. So it does exactly the same thing for serial 0. It sets up serial 1 the same way, in that there's going to be no parity, one stop bit, 8 data bits, 19200 is the baud rate, and we're not going to have any interrupts. All the interrupts are disabled. We don't use interrupts in CPM 2.2. And then our serial ports are configured and ready to run. There's no configuration required for the parallel port. It's a basic I/O, very basic. It doesn't really do a lot, but it's a very useful chip. And as we move down here to the bottom, closer to where the actual devices are configured, these I/O handler section, well, there's our console port. So this is the console status, and this is console in and console out. These haven't changed. But when you get down to the list device, this is the driver for the parallel port. And all that's happening is that when you call list to send a character to the printer, it's going to ask, what it's going to do first thing is going to check the status of the printer. And that's down here, list ST. And it's just looking for, is it busy? Is acknowledgement ready? Is it out of paper? Or has there been some odd error? If any of these occur, then it's going to wait. Essentially, we're going to just go back and forth and wait until the printer is ready. So you can see it starts off with calls list status. If it's not ready, then do it over and continue to check status until the printer's ready. And this is common for CP/M, that you'll have a printer driver or something like that, and the printer gets hung up or offline or out of paper or something like that, and the whole computer locks up until you get the printer running again. And that's going to happen on the 8080 computer. That's pretty much the way it is. You could print out an error message, but you're probably going to disturb the screen. The console, whatever application you're running, it's going to have that error message plastered over it. So I didn't want that, so I didn't do that either. It's just going to hang the computer until you fix the printer. And the rest of this is, again, is just sending data out the printer. And the way you send data is that you'll put the character you want to send to the printer in the data register. And then what you're going to do is turn on the strobe bit. And that's going to strobe that character into the printer. The printer will then accept that character. And the only thing I'm going to be looking for is the busy bit. So I'm just going to be looking for, is the printer busy printing that character I sent? And if it is, I'm going to wait. And if not, it's already printed it, then I'm going to move on. That was really it. Now on the punch and reader side, this is where serial 1 comes into play. Punch is an output device, and so I'm using TX Ready, and I'm sending data out to serial 1. So punch is going to be an output-only device. The reader is an input-only device. Notice I'm using in instructions here, so that I'm only taking data in on the reader device. But when I'm using Kermit, Kermit goes directly to the hardware. It goes directly to the serial port. It doesn't use punch and reader, these two devices, to do that. I'm going to show you that code in a minute. But that's really all that's all that's been changed, is adding drivers for these 3 new devices: list, punch, and reader. It's very simple instructions that probably took me an hour to write this. It actually took more time to research how the printer works than it did to write the code to control the printer. So that's typical, right? You know, it takes more time to understand how a device really works. But once you have that understanding, it doesn't take hardly any time at all to write the driver. Let's take a look at Kermit. So Kermit is broken up into 2 major components. You have your system non-specific components. This is software that will run on any computer as long as it's got an 8080 or a Z80. And then there are system specific components, and that's to account for all of your serial ports. There were all these different computers at the time Kermit came out, and they had different I/O. Some had CRT consoles, some had terminal consoles, some had serial ports like the 8250 or the 8251, and some had a different manufacturer's serial port, and some were bit banging. So that essentially what you're looking at here is the main component for the system dependent code. And so really, to get Kermit running, you just need to make changes to the system dependent code file. And this is one I created specifically for my 8080 computer. You can see I've got the same equates that I used in the CBIOS, and it's actually pretty easy to use. The non-system dependent code is going to be making calls to these functions. It's essentially going to call these functions, and then all you have to do is put the code in for those functions. One of them is initialization, and all I do in initialization is I set up the 8250 serial port that I'm going to use for the modem, the second serial port. And you'll notice that, wow, this looks real familiar. Well, it came right out of the V3 BIOS. And then sysexit, what do you want to do when Kermit exits? Well, I want to if I've changed the settings for the serial port, I want to put them back the way they're supposed to be. And so all this does is jump back here and run this and then exit. And then there's a lot of functions that I don't need. My computer didn't need anything here, so it's just a return. So there's a lot of returns. Then there was like one message for transmitting a break, so I put that in there. So this sysint, this was for sending a break signal, so I put code in there for that. A lot of just returns does nothing, returns does nothing, and this changes the serial port speed, the baud rate on the second serial port, and this table's got what valid baud rates there are, and then the rest of it is you get down to I/O, and so this is getting a character from the console, sending a character to the console. This calls BDOS, which will then call the CBIOS drivers for the console. And then this is modem, so there's an out, send a character to the modem, get a character from the modem, that's the serial port that connects the two computers together. And this looks familiar too because I copied it out of the CBIOS and used that. And there's a flush command, and that's just read until there's nothing left to read. That's all there is to that. And then the LPT stat, there, you don't do anything with LPT stat because there's nothing you really do with it. So that's just essentially do nothing code. And then there's output data to the LPT port, and that's just calling BDOS as well for the list device. So I didn't really have to do anything. No special driver here, it just calls BDOS. And then the rest of this is for an ANSI terminal, VT100. So this is all just processing for things like moving the cursor around, clearing the screen, moving the cursor up and down, things like that. So that's really all you had to do is, and this stuff I copied from another, there were all of these different configuration files in the package for Kermit. I just borrowed this code, and same thing for this here. I borrowed a lot of this code. So there's not a lot I really had to write. Then after that, you just assemble it and you get a working Kermit. Well, that's everything I've done to the computer. I've added that drive indicator light, which I really like. I've added the I/O bus and the I/O expansion card, and I've got now an additional serial port and parallel port, so I'm able to run a printer. I'm able to connect two computers together and transfer files over a serial line, and that works really well. The terminal that I'm attached for console works really good. I'm going to do an article on that here shortly, because I think there are a lot of people that would like to know, how can I build a serial terminal cheaply that works just like the terminals from many years ago. So I'll end up doing that. And so all these upgrades I think have made this computer much more usable. The console and serial port and parallel port connections on the back make it look more like a real computer, a real product, instead of just the science project with wires coming out of the back. And so overall, very happy with the computer now. I think these upgrades were certainly worthwhile. And with being able to run this Kermit software, that was one thing I really wanted to be able to do. But you have to have a second serial port in order for that to work. Yeah, it's been a lot of fun. And I'm going to be posting this source code on my website here pretty soon. Many thanks for spending some time with me on this project, and hopefully I'll have some more interesting projects coming up soon.